Okay, we'll be doing a lot of factoring, and so I know it's been a while since you've done factoring, but we need to kind of walk you through the steps of taking a quadratic, a parabola. Obviously, this is kind of a parabola type situation, and seeing how to factor it. So what we're going to do is we're going to take this and we're going to split it up into two things. Now, I need two things that multiply together to give me x squared. I believe you'll remember something like this. You have x and x. The next thing that you need to understand or try to figure out, two things that multiply together to give you 10, but add up to 7. Because what we're going to be doing here is, we could look at things like 10 and 1. They multiply together to give me 10, but they do not add up to 7. So you look at other choices. There's not a whole lot of choices with 10. 5 times 2 is 10. And that would be exactly what we want. Now, that's one acceptable answer. Here's another acceptable answer. X plus 2 times x plus 5. There is absolutely nothing that says you have to have one factor in front of the other. Now, we're going to find out that sometimes you're going to have different signs, and those signs do make a difference. In this case, they don't make a difference because they're both positives. And so here's another example, same type of thing. Two things that multiply together to give me x squared. Well, that's pretty easy, right? X and x. But then, what multiplies together to give you 18? Well, there's 18 and 1, there's 2 and 9, there's 3 and 6. So, a couple choices here, but what they need to add up to, and the reason I know that they're adding up to a value is that sign right there. And what do they have to add up to? They have to add up to positive 11. In this case, that would be positive 2 and positive 9. They add up to 11. And once again, it would not matter if you said x plus 9, x plus 2. There's nothing magical in terms of that since they're both pluses. So, same type of thing here. Do yourself a favor, pause the video, try this, see what you get. So pause it. If you see if you get the correct value. It should be x and x, and then think about numbers that multiply together to give you 54 but add up to 15. Correct answer would be 6 and 9. And if you're curious about how to double check that, you take the insides and the outsides. Remember the FOIL process that you did back in Algebra 2, or Algebra 1 I should say, where you multiply them together and see what you get. Like the insides there would be 6x and the outsides would be 9x. So when you add those together, you get 15x. Factor the expression. Okay, so this time we're coming up with things that, so we got an x and an x. I guess I could have put this down in the answer blank. Now this time they need to multiply together to give me 5. Well, there's only one choice. It's 5 and 1, right? So I don't care if you put the 5 here and the 1 there, or the 1 there and the 5 there. But what's different about this question is they have to add up to -6. Now, the only way that can happen is if both of these are negatives, because your insides would give you -5x and your outsides would give you -1x, and if you add those together, you'd get -6x. And once again, like I said before, it doesn't matter to me whether you put the -1 first and the -5 second. Since they're both the same, I'll take this answer, I'll take this answer. It's not going to matter to me. Okay. 5 is very similar. Going to have the whole two minuses. Okay. Think of numbers that multiply together to give you 24. Well, there's 24 and 1. Well, they add up to 25. There's 12 and 2. That ding, ding, ding. That's it right there. 12 and 2. I didn't have to go very far because they add up to 14. And they're both negative. That's why you end up with that whole -14x thing going on. All right, now what happens if there's a minus sign down here? how is that going to change? Well, the only way you'd get a product, remember this has to be a product of negative 18. The only way you could get a product that's negative is that if one of them's positive and one of them's negative. So, and it really doesn't matter which one you put the minus in and which one you put the plus in. Now, what does matter is what you put next. For instance, so my numbers, since one of them's positive and one of them's negative, and when you're adding a positive and a negative number together, that's like subtraction. Okay? That's kind of the idea. Running out of room here. Subtraction. So, now technically you are still adding the numbers together, but because one's positive and one's negative, it kind of gives you the feel of subtraction. I need two numbers whose difference is 3, specifically negative 3. So 18 and 1, their difference is not going to be 3 or negative 3. 9 and 2, their difference is 7 or negative 7, but definitely not. So we're dealing with 6 and 3. Now the question is, which one gets the 6 and which one gets the 3? It's really important that you understand that the larger factor goes with the minus. In this case, it's minus because we need that middle term to be negative. Okay? It wouldn't matter to me if you put x minus 6 and x plus 3. Those are both, these are both acceptable answers. What's not an acceptable answer is if you say x plus 6 and x minus 3. That is not an acceptable answer. Here's why. Because when you do the insides and the outsides, you don't get a negative 3x. You end up with a positive 3x. Right? 6x and a minus 3x does not give you what you're looking for. So that's actually not the correct answer. So while I'm okay with you switching the factors, I'm not okay with you switching the signs. So let me see if I can find another one of those. Come on, it's got a minus at the end. Something cool. Okay. No, that's kind of... Oh, this has got a little bit more of that same flavor. Although I see something interesting in this particular question. This, and if I'm asking you to factor this, truthfully, the very first rule of all factoring is factor out a GCF. That's greatest common, oops, can't spell, greatest common factor. In this case, it's a 7. And what you're left with in this is x squared minus x minus 6. Okay? And so now this is that same concept we were talking about earlier with a minus at the end. So 7, and then we're going to break this part up into 2. We got x and x. Now, factors of 6, whose difference, right, that because I see a minus there, I know it's a difference of, in this case, a difference of negative 1, right? So factors of 6, we got 6 and 1. Well, their difference is like 5 or negative 5, and so 3 and 2. So it's got to be 3 and 2 because they have a difference. So it's important that you understand one's a plus, one's a minus. Where does the 3 go? Well, the 3 has to go with the minus so that when we do the outsides and the insides, we end up with a negative 1x, right? 2x and a minus 3x equals a negative 1x. So this is one acceptable answer. Or, just like I've said before, you could do the x minus 3 first and the x plus 2 second. That's another acceptable answer. The 7 does have to be on the outside because it is the greatest common factor. It was pulled out first, and then the remaining work was done after that. Okay. I think that is enough of that type of practice. All right. Now we're going to get into a little bit more difficult ones. You know what? I'm going to skip 7 and 8. I'm going to jump to 9 for the moment. This one, another way to write this is x squared plus 0x minus 121. Now, nobody's going to write this middle term. It's always assumed to be 0, so you don't have to worry about it. But it helps kind of illustrate what's going on here. We want two factors. You got your x and x. I need two numbers that multiply together to give me 121. Well, things like 121 and 1, 11 and 11. But the difference has to be 0. Well, that has to be this choice right here, because the difference between 121 and 1 is 120. Now, how do I get a difference of 0? Remember, this is the one where it's one is plus and one's minus. They're both 11. And like I said, it won't matter whether you have x plus 11 first or x minus 11 first, as long as you have one of each. This is called a difference of perfect squares. Oops, sorry. Difference of perfect squares. Here's another difference of perfect squares. Now, notice that the first thing's a perfect square. Notice that the second thing's a perfect square. Also, notice that there's no middle term, right? That middle term has to be that 0x thing. It's a difference of two perfect squares. Okay. So if I take So basically what you want to do is take the square root of each one of these. So that'll give me 4x and 4x. 7 and 7. One's a plus, one's a minus. Well, let's see if this works out in the middle. Well, there's 28x. And there's negative 28x. So that is indeed what the answer is, because those two things would cancel each other out. Like I said, it won't matter whether you have, won't matter whether you have the plus first and the minus second, or minus first and the plus second. Not going to matter at all. 11 is just more practice. 13's another, well, 13's the exact same difference of perfect squares. Whoa, look at 14 though. There is a 3 we can pull out. Remember how we said factor out GCF? And that would be our first step. Okay, well, if I do that, I'm left with a squared minus, let's see, 81. Okay, now I do that, and look, a difference of perfect squares shows up. So we can continue this process. We can take, remember how we talked about, square root of this, square root of that. So I got an A and an A, a 9 and a 9. One's a plus, one's a minus. It doesn't matter which one it is. So that's question 14. Sometimes the GCF, like on question 15, sometimes the GCF is more than just a number. So for instance, I can see that, these two things have a 6 in common. But they have more than that. They have a 6x in common. Now let's look at what's left. Now when I say factor out, factoring out is is another word for saying divide. You need to understand that. Factoring out is using the process of division, basically to rewrite something into two factors. So if I'm dividing out, if the 6x is coming out, what's left? Well, if you take that and divide by 6x, you're left with 3x. If you take 42x and divide by 6x, you're left with 7. And that is the correct answer to this question. There's nothing more that can be done with this. When you pull the greatest common factor out, that's it. You can't factor it any further. Nothing else can be done with that. That is the answer. Well, I guess this has an answer blank all the way over there, but let's see here. This also has a GCF. I can see that 5 goes into everything, but I can also see that an x can be pulled out. That would leave me, so I'm dividing everything by 5x. That would leave me with 7x minus 2. There you go. Final answer. Can't do anything more with it. Sorry. Okay. Oh, it's got another 7. That's got a 7 in it you can pull out. That leaves me with b squared minus 49. Oh, there's a difference of perfect squares. I can factor that even further. 7 times something. So, like we said before, take the square root. Take the square root. So it'll be b and b. 7 and 7. One's a plus, one's a minus. Now 19 is an interesting one. Please, 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 please draw a picture. So many people don't draw a picture. If they did, they'd understand it. The area, well, how do you find area? Area is equal to length times width. You guys all know that. Now, if the width, so we know the area is equal to this thing right here. If the width is x minus 30, what's the length? Well, folks, this is actually easier than the previous questions because instead of them making me factor it all by myself, they've actually given me one of the factors. So how do I do this? Well, think about this. What two things multiply together to give me 2,400 if one of them is negative 30? So something, I don't know, what do you want to call it? Let's call it, we'll call it capital B. Negative 30 times capital B is equal to 2,400. Because those two things have to be multiplied together. Whatever's going to go in there, we'll call it B. They have to multiply together to give me negative 2,400. So you're just dividing, right? 2,400 divided by negative 30. Well, let's see here. That would be, I can get rid of a 10 from the top and the bottom, and then 3 goes into 240 80 times. So that ends up giving me a B value of negative 80. Which means my factor is x minus 80. That's the answer to my question. That is the length. So basically, this is an easier factoring question than the other ones because they gave me one of the factors. All I had to do was come up with the other factor. And a little bit of division is all you're going to do. That's all you have to do. Now, we have skipped a few questions. Some of them are more difficult questions because they involve a process. Now, when I was in school, they made me guess and check. That is not all that fun, folks. So, what I want to practice with you is something called the Berry method. Now, it was the actual proof. I went online to look at the actual proof, and it is nasty, 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 and I would never expect you to know it or prove it to anybody. Okay? Basically, we're going to look at, if I had to boil it down to you, I would boil it down by graphing it. And I can do that in class. Or I actually could show you here quickly. But the process of factoring with the Berry method is pretty straightforward, and I wish somebody would have taught me in high school, but nobody did. So I'll walk you through it. It's going to look like a double magic trick, by the way. So the first thing I'm going to do is I'm going to mysteriously pick up this 12, and I'm going to multiply it by the 3 at the very end, creating a new, basically a new parabola. Okay, so it really looks like I picked up the 12 and I multiplied it times the 3 at the end and changed it to x squared plus 13x plus 36. Now, you know that when you're factoring, you're coming up with two things that look exactly the same. They're just in different forms. Like, for instance, if I said, give me the factors of 6, you'd say 2 times 3. Those are factors of 6. They're prime factors, by the way. But it's rewriting something exactly the same. These two things are not exactly the same. That's why this proof is, if I showed you the actual algebra, you would hate me forever. But hopefully none of you do that already, but I guess we'll find out. So what I want you to do with this new parabola is I want you to factor it. Well, this one isn't too bad to factor, right? You got x plus, and then you need factors of 36 that add up to 13. Well, that would be a 4 and a 9. It's definitely not 6 and 6 because they add up to 12. It's not 36 and 1. It's not 12 and 3. It's 4 and 9. Okay, there's lots of options with 36, but 4 and 9 do add up to 13. Now, I'm going to create a new parabola. Okay, this new parabola, remember the 12 that just kind of vanished from the beginning? Well, that 12 is going to mysteriously reappear. Now, this new parabola that I just built in the red has something in common with the original one. These two things have same x-intercepts. Now, I know that probably isn't making a whole lot of sense. What do you mean by they have the same x-intercepts? It means they cross the x-axis in the same place. And what we're going to see in the near future is that we are looking for these things called x-intercepts, or sometimes more commonly referred to as zeros. There is something that needs to be removed. In order to get this correct, I need to go through here and I need to pull out any greatest common factors. Because in this process of changing these, I've actually thrown in some numbers that aren't true. For instance, inside this first one, I see that they have a 4 in common. I'm going to pull it out. If I pull out that 4, that leaves me with 3x plus 1. And when I say pull it out, remember, it's a greatest common factor. So I pulled out the 3, and I'm literally going to throw it away because I don't need it. Now, if I go over to the other one, what does it have in common? It has a 3. I'm going to pull out the 3. So I'm actually pulled out a 4 out of this one. I'm pulling out a 3 out of this one. Okay? And if I pull out a 3, I get 4x plus 3. So that's the actual answer to my question, 3x plus 1 and 4x plus 3. As long as the factors are in the same place, it doesn't matter whether you put the 3x plus 1 first or the 4x plus 3 first. That's the Berry method. So if I were to just go through this quickly again. So first I have the miracle, take the 12 and multiply it times the 3, and that's where the 36 comes from. Then I factor it the normal way. And that's how I got the x plus 4 and the x plus 9. Then the 12 comes back in front of both x's. Then I take out any GCFs that do not belong. All right, now I'm going to quickly show you. We're going to have to practice this method a bunch in class so that you get good at it, okay? But I want to show you. So 12x squared, I'm going to come over here to desmos.com. Come on, where are you at? DSMOS, desmos.com. Y equals 12x squared plus 13x x plus 3. Okay. So here's a parabola. It crosses the x-axis, and what we found out and what we would find in class. It crosses the x-axis in two places, at -1/3 and at -3/4. Okay, and I'm really looking for those places. Eventually, we're going to be doing that kind of thing. So the reason we're going to be factoring this is so that we can find what we call the x-intercepts, or the zeros. Well, the first version of this that I came up with, remember I took the 12 at the beginning, and I multiplied it times the end. Remember I said to you I create a whole different parabola? Well, you can obviously see that the blue one doesn't cross the x-axis in the same places that the red one does. But, well, what happened? Okay, there it is. All right, now, after we go through the process of factoring, y equals, and we get it down to, let's see, 12x plus 9. Now remember, this is the one that doesn't have the factors removed. And then what did we have? 12x plus 9, and the other one was 12x plus 4. Okay. The green one and the red one are not the same, but I am going to zoom in so you can see what's going on. Something interesting is happening. They go through the exact, even though the red and the green are not the same, the cool part is, whoa, don't move it around. The cool part is that they have the exact same places where they cross the x-axis. Okay? And that's how we can use this process to end up with the right factors. Now, I'm not saying you won't need practice. Let's see if we can do another one quickly here before the end of our video for today. This one actually has a greatest common factor before everything needs to get factored. So let's try that first. Looks like there's a 5 in common. That 5 is going to get pulled out. And by the way, you cannot use the Berry method unless you have first pulled out a greatest common factor. The Berry method does not work if you don't have a GCF pulled out. So if we try to take the 25 times the 10 and do all this stuff, it wouldn't work. So we pull the 5 out, and it leaves us with 5x squared minus 9x minus 2. Okay, so in my final answer to this question, I'm going to have the 5 out in front. You cannot ignore that. That's part of the final answer here. But now I am going to focus my attention on the part that's on the inside. So essentially what I'm going to kind of do is ignore the 5 that's out in front. Even though I know that 5's in my final answer, I'm just going to kind of deal with what's on the inside. And over here on the side, I'm going to do my Berry method. So x squared minus 9x minus 10. Okay. So, oh, I lost my power cord. Oh, yeah, somebody unplugged me. Okay. Gotta hurry up. So anyway, if I factor this the normal way, x squared, x and x, because this is a minus 10, one's got to be a minus, one's got to be a plus, and I need factors of 10 whose difference is 9, in this case negative 9. So my negative 10 will go here and my 1 will go there. Okay, well this will be our last example and then we'll be done. In front of both of the x's, this 5 that was over here is going to return. 5x minus 10, 5x plus 1. Now, Is there a GCF inside the first one? If so, pull it out and get rid of it. You can see that it has a 5. So if I pull that 5 out, it's an unnecessary 5. I'm left with x minus 2, right? I can pull out the 5. The 5 is useless. It was extra that we didn't need. That's not the same thing as the original 5. That 5 is necessary. This Berry method process, now if I look over inside the other one, I don't see anything extra, so it is finished. That's it, folks. These are the two factors that are going to be written over here. Now, it doesn't matter in what order they're written in, as long as you have one of each. But that's my final answer, my final factored form answer. Okay? And we will practice more and more of this stuff because I know that you need to practice with me. Okay? And we'll do more of that kind of thing. Okay, great. Got almost all the way through the 3-4 notes. Awesome. Have a great day.